I am Bisqwit, and in this series we crack video game password generators.
Previously on Cracking Video Game Passwords.
Now, to study the meanings, it may be necessary to give each bit a name. For the other bits are rotated by this number of positions, both faster and shorter, but it does reverse the order of the bits compared to the canonical way to do it. I very much prefer when things are done with few statements rather than with many.
And now on Cracking Video Game Passwords. Swords and Serpents. Is it a 3D game? Is it a role-playing game inspired by Dungeons and Dragons? Is it a game suitable for cracking video game passwords series? Yes, it is. In Swords and Serpents, first you input a name and then you enter a password, and then you input a name and then you enter a password, and then you input a name and then you enter a password, and then you input a name and then you enter a password, and then you enter a password. Let's go over that a little slower. The passwords in this game are made of alphanumeric symbols, which there are 32 to choose from. From this it follows that 5 bits are packed in each symbol. The selection almost carefully removes pairs of symbols that can be accidentally mixed up when writing down. Here are some example passwords. It is interesting to note that the passwords do not have a fixed length. The maximum length you can input is 20 symbols, but valid passwords are always 14 letters or shorter. Speaking of passwords, plural, did I already mention that you have to input 5 passwords in this game? No, that's not all. You also have to input the character names. Exactly, precisely, letter to letter. Any error in one of those 9 strings will make your game unrestorable. This means a maximum of 124 letters you must input. So let's study the password structure then. The password is a 128-bit integer. But the NES is a 8-bit machine. Sounds like they were seriously ahead of their time. A 128-bit integer on an 8-bit machine. How is that even possible? Let's have a look. Here is some of the assembler code that deals with this 128-bit integer. First, there is this routine that simply clears the password. The 128-bit integer is technically a 16-byte array in the game memory, the same way as a 32-bit integer would be a 4-byte array. The function loops through 16 bytes in the memory and stores 0 to each of those bytes. Another routine calculates a checksum of the password. There is a similar loop as before, where 16 bytes are processed. This time, instead of writing a 0 to each byte, the byte is read and arithmetically added to the accumulator. Interestingly, it only keeps the 3 low bits of the result, making it actually an extremely weak checksum algorithm. We will get back to that later. There are only 2 more routines that deal with the password. Just 2. They are shown here. Pretty simple, huh? It's best to explain this visually. To understand how this extra white number is manipulated, let's give each bit a distinct name. There is no language with 128 Latin letters, even though Tiang Viet comes pretty close with its tonal markers. I took therefore the liberty of mixing symbols from a few different scripts. Don't worry, these are just graphical markers to help your visual cortex better track motion. As we explored earlier, there are exactly 4 different operations that the game does on the password. First, there is the clearing of the password. It doesn't do anything very surprising. Then there is the insertion. A number is inserted into the password. For example, let's insert the symbol H from the password alphabet. This means number 13 or 01101 in binary. The insertion process reads the binary number bit by bit, starting from the right, and pushes each bit one at a time into the long integer at the less significant bit. Let's do another letter A this time. Once more, each bit is successively pushed into the integer. In the process, their order is reversed. Then let's study the extraction process. Let's pop a 7-bit value from the integer. One at a time, a bit is extracted from the less significant end of the number and pushed into the result. Once again, the value is reversed in the process. But you know what happens when you reverse something twice? You get the original back. If you first reverse something when inserting, and then again reverse when extracting, you get the original bits out in the right order. Here is the assembler code again. It is really quite straightforward. Technically it could be somewhat shorter. With 20-letter passwords you only need 100 bits to store the data, which means you could do just fine with 13 bytes instead of 16 bytes. And in fact, because the longest valid passwords are 14 letters long, you only need 9 bytes. The game does too much work and wastes memory, but maybe it doesn't really matter, and the interplay can still have good conscience, considering that it took quarter-century for someone to find this out. Here are the 2 remaining functions. All the manipulations of the password happen through these 4 pieces of code. Now let's study the actual data content in the game. I'm going to use my trusty little editor here. The editor runs in DOS, but that's just a video production convenience thing. You can use any editor you like. I do all my coding normally in Linux, and this editor does not run in Linux. So there are 4 player characters. Each of them has a name, a profession, and some stats like strength, intelligence, agility and maximum hit points. They also have an inventory and a list of spells if they are a magician. Globally the game has a player level, the map index, coordinates on the map, and money or treasury. There is also flags that indicate whether something is done somewhere. In the core of the password encoder and decoder is, well, a password. A single password is essentially a 128-bit integer, as we clearly established earlier. First and foremost, we need input and output methods dealing with the password. First, a method of inserting bits into the password, and also a method to extract bits from the password. These are pretty straightforward combinations of bit shifts and OR and AND operations. No surprises there. Well, they would be normally. But the game reverses the data. Because the checksum calculation depends on the exact representation of the bits within the 12-8-bit integer, the reversal must also be implemented here. My algorithm for bit order reversal is rather complicated and difficult to explain. Basically it swaps different groups of bits in parallel several times. It is the most efficient one that I know for general case, barring lookup tables. There are ways to improve it for some special cases. The value is reversed when inserting with put bits and reversed when extracting with get bits. Next we need a method to convert a string of symbols into the password integer. First and foremost, the symbols must be converted into numbers, and that's when we need the password character set. The password is processed in the reverse order, from last letter to the first one. Anything that is not a space is looked up from the character set and then inserted as a 5-bit number. Then the same in reverse, converting the password into a string of symbols. This is easy. As long as there remain bits in the password, extract 5 bits at a time and translate them according to the character set. This process does destroy the contents of the integer, but since C++11 there is a way to document this clearly and force it in type checking. Adding 2 ampersands in the function signature indicates that the function can only be called in R-value reference contexts. This literally means the following. This operator can only be called when you don't care what happens to the object after the call. The compiler enforces this. It's quite convenient. Then there is the checksumming function. As we discussed earlier, the game adds all the 16 bytes together and then discards all but the 3 load bits of the result. This design lends itself to a very efficient implementation where much of the calculations are done parallel. Now there is one problem with this code so far. There is no 128-bit integer type in C++. The highest that the standard defines is actually 64-bit. While that is quite inconvenient, it is not the end of the world. After all, the game itself did just fine with 8-bit integers. Some of the mathematics must be done in 2 or more parts. Now on to the actual encoding of the passwords. First, there are the 4 per character passwords. Each password is encrypted. The encryption key for the character password is the sum of all bytes in the character name. This sum will be used to XOR each data item that is written into the password. Conveniently for us, the character names are actually treated as ASCII, so no character set conversions are necessary here. First, the game puts the character's profession into the password. The profession is a 2-bit integer. Next in goes the inventory. There are 6 slots, but only the non-blank slots are saved. Because this means variable amount of data, the game must also save the number of items in the inventory. This number is 3 bits wide. Next in go the character stats. Maximum hit points, agility, intelligence and strength. The game actually caps each of these stats at a certain value, and there is no way to make the game load invalid data in these stats. Finally, a checksum is calculated of the 28-bit integer, and the 3 low bits of that checksum are stored. That completes the character passwords. The 5th password is the game password. It too is encrypted. The encryption key is the sum of the encryption keys for all the character passwords. First in goes the treasury as a 14-bit integer. It is split in 2 parts to make it more convenient to write on an 8-bit computer. Then goes the game progress. Instead of storing the full map number and coordinates, the game only tracks which temple was the last one you saw. This number is 2 bits wide, but number 3 is not used. Then goes the player level in 5 bits. The flags tell whether a money bug has been collected in some room or not. There are 26 of those flags. There is also Iti and Pity. Instead of saving the list of spells for every character, the game actually only saves the list of spells from the first magician in the party. If there are no magicians, no spells are saved. If there are multiple magicians, the game assumes that all of them know the same spells, because only the spells of the first magician are saved. Finally, a checksum is placed, just like with the character passwords. And here you see how to use the R-value conversion operator. That completes the encoding of the passwords. Next, let's focus our attention on the decoding. Obviously, the process should be pretty much the exact reverse of the encoding. Usually it is considered good style to first write the decoder and then the encoder, but for this video I wrote the encoder first because it is simpler and more straightforward. The source code I wrote serves to document the password format better than the source code for the decoder I am writing right now. But suppose you are designing a new compression format. You should always first design and document the decompressor, not the compressor, because you want to make sure that it is actually possible to extract all the data it is supposed to store. Otherwise it is possible that your design actually destroys data and you don't realize it until it's too late. So as before, we load the character stats. They were saved last, so they must be loaded first. The game actually disqualifies the password if those stats are not in valid range. Here we just produce a warning. The warning is passed to the calling function using the supplied functor, which decides what to do with it. Now the inventory. The inventory contains room for 6 items, but the number of items, being a 3-bit value, can actually be 7. If the inventory stores 7 items, the 7th item actually overwrites the list of spells. Also, the game prohibits certain items from being loaded into the inventory, so you can't open portals into Pokémon and conjure up a missing node to fight your battles for you. Next is the profession. There are 3 possible professions, but the game actually loads a 2-bit value, meaning that 4 professions are possible. However, in all my tests, I only saw that the game just treats profession number 4 the same as profession number 3. Loading the game password begins with verifying its checksum. Then the list of spells is loaded, but only if there is a magician in the party. The same list of spells is assigned to all magicians, and the rest of the party members get 0, meaning no spells. Note that this actually cancels any damage that may have been caused by having too many items in the inventory. If there is no magician in the party, the list of spells is left untouched. Iti and Pity are 2 data bits that I haven't been able to figure out what the game uses them for. For some reason, they are stored separately from the 26 other bits that indicate whether money has been collected somewhere or not. There are 3 temples in the game. A 2-bit variable tells the game which one to restore the player into. This means that 4 locations are possible. The 4th location is garbage data from the game ROM. I don't remember if it crashes the game or not. So that's the password encoding and decoding. The rest of this program is just framework to make the program marginally usable. And I can breathe free, because I no longer need to sync my lines and re-encode the video after every sentence to match the pace of the source code with the pace of the narration using my DOS-based tools that are somehow exotic enough to put a certain unique touch to my channel. Should you want to try this program yourself, check the video description for the download links. I'll always try to put useful information in the video description. While I still have about 30 seconds of time, I will share with you this random fact that you might not have known before. I can no longer add annotations to my videos. When YouTube added the end screen link feature, they forced content creators to choose between having annotations and having the end screen. You can't have both. I choose to have the end screen, and therefore I can no longer add annotations. So if there arises something I need to say after this video has been published, I must do it through the video description. Always read the video description, it is there for you. Remember to click show more. Now I can't just end the video here, can I? No, I can't. Now if my calculations are correct, within just a few days after this video is published, my channel is going to hit 20,000 subscribers. And this is thanks to nobody else but you. Really. When I created this YouTube channel, I had no idea it's going to hit this big. Well, nobody can expect that kind of things. It is thanks to every one of you who have advertised my channel, for example on Twitter, on Reddit, on YouTube, on Facebook, on any other channel, maybe in your company. Maybe to your friends, maybe in your school. It's thanks to every one of you. And also thanks to everyone who has contributed to my Patreon campaign. I don't have any words to thank you enough for that. It's quite unexpected. I'm just a nobody here in Finland, here in North Europe, in a little country that nobody knows about. Speaking in a weird accent that nobody can recognize and pinpoint where it is. Except maybe other Finnish people. So when I created my channel, it was only just to provide a possibility for me to upload some kind of videos. If you check my oldest videos on my channel, they are not very impressive. But then I uploaded some programming videos and it started slowly and slowly getting more subscribers and so on. And even that I did because at TAS videos, many of you probably know I created TAS videos, that's another story. But at TAS videos, on the TAS videos forums, I sometimes published there. I wrote some small snippets of source code that were fascinating to me, because I like reading source code, so I wanted to share that experience to other people, giving the possibility to read source code. That's what I wanted to do. And I wanted to try a different medium for that, so I did it in YouTube. Initially I didn't have my fancy automatic typing system that I do nowadays, which I wrote from scratch, of course. So I used DOSBox for that because I had too slow computers to record anything in real time. So I used DOSBox, and DOSBox has had this funny feature that when you crank the cycles high up enough, then whatever you record, when you play it back, it appears sped up because it doesn't run in real time when you record it. So I was able to make a snake game and some other programs that appeared to be typed quite fast. And people like those videos, so I invested more time in that and created some more ambitious projects. Initially I tried to keep my videos, the source codes, I tried to keep them in like 1 or 2 or maybe maximum 3 A4 papers, like this size papers. I try to keep them small so that I don't have so much to type, because anything that if I make typos and such, it's not so nice to watch those. It's nice if the video is relevant and you can see some actual functional software that does something useful. So I try to keep them small, but as I went for more ambitious projects, I kinda had to discard that goal. So I invested in creating something that could automatically type the source code, as was done in this very video, assuming you are watching this as part of the Cracking Video Game Passwords episode 12, and not as a separate video, which I may cut from this video sometime in the future. So that led into me making some of the most popular videos on my channel so far, the OpenGL 3D walking example, the NES emulator, what else was there? The 3D engine, the Doom style thing, and also, well, none of the others are so popular. There's the Chip 8 emulator, and there's the Microprase emulator, and there's many other stuff, but they are not so popular. But it kinda has led me in that kind of progression. And this year, a couple of months ago, I started that Cracking Video Game Password series, which is not so popular, but it is something I have been wanting to do for a long time, because that kind of stuff fascinates me. So if some people enjoy it, it's great for me. If it attracts new viewers to my channel, it is also really great. So what do I want to do with this channel in the future? Well, I kinda want to keep doing the same things I have been doing so far. For example, I want to keep doing programming videos. I kinda want to keep doing this Cracking Video Game Password series. I'm not sure what to do with it so far. I have a couple of games in the list that I haven't done yet, so I should probably do those. Then I have some other series that I have in mind. For example, I want to do a series that explores how different NES games scroll the video. It's it's really fascinating topic to me, at least, because the different games, they do it differently. Different developers do it differently. So there is a lot to explore there. So I kind of want to do that kind of series, but I haven't kind of figured out a good format for it yet. So that's one of the ideas. And then I may do some Let's Play. I don't know, I'm not really good at that. Some gaming related stuff I will probably do anyway. One of my most popular videos is that the Stanley Parable Bomb Ending Secrets. Sorry. I try to remember those little instructions you people give me about pronunciation. Bomb ending secrets, explosion detonation ending secrets. That's one of my most popular videos. It's not about programming, but I do kinda crack and hack and investigate a game there. I kinda want to keep doing that kind of content. It interests me. So about schedule. I can't really promise any regular schedule, and I kinda don't want to make promises because it just paves way for broken promises. As for this Cracking Video Game Passwords episode 12, I was planning to make it in like a week or two after episode 12, but then I got really tired. I have been having asthma and things of that nature, and I really have to expend and concentrate my energy on my work, because I'm still new there, so I have to focus. So that's why there was about 2 weeks of time, maybe 3 weeks of time where I did absolutely nothing for the episode 12. I recorded most of it today, so that kinda shows how it works for me with regards to promises and schedules, so I can't promise anything, and I'm really thankful that you guys are patient with me. When sometimes I don't publish anything on my channel for many months, and then I may sometimes publish many videos in a week. It kind of works like that way. I don't make any promises. I don't keep a buffer of videos. Anything I publish, I make it and then I immediately publish it. I don't keep a buffer. So what else? About other genres. Well, there's two things I have in mind, probably. As I have mentioned before, I teach Israeli folk dance, but I'm not going to make videos of Israeli folk dance because of copyright issues. It's a minefield. Music is a minefield, so I'm not going there. And the other is about Bible topics. I know when I made the previous video where I scratched the surface, where I explained about my test card pictures and the Philips and so on, and then I moved on to the Guts Learning channel and explained something about Guts Feasts. I was just scratching the surface, and the reception was quite mixed. Some people really liked it, and they sent me encouraging messages and feedback, and I really appreciate that. And then there were some people who didn't like it, but they watched it and didn't say a word. Good for you. And then there were some not so nice people. I'll just leave it at that. So I kind of want to make videos in which I teach about Guts Feasts and other topics. But I'm not sure where to do it. I may make a new YouTube channel for it. I'm not sure so far. I probably I'm not going to do it on my main channel. So that remains to be seen. So about Patreon contributors. Well, I'm not really a sales type person, and I can't offer you a compensation if you donate something to me. If you donate something to me, it is purely out of support, and actually for taxation reasons, I cannot even promise that I give you something in return, because that would be sales then. That would not be donation, that would be the sales, and I would have to pay different kind of taxes for that. So that's not going to happen. But if you become my patron on Patreon, you do gain access to some things that other people don't see, but I kinda haven't figured out yet what to do with that, because when I make videos I release everything free of charge, as links in the video description or otherwise, so I'm not going to withhold those of anyone and make them so that you have to pay to get access to them. No, I'm not going to do that. As for getting early access to my episodes or other videos, no, probably not going to do that. I'm not disciplined enough to withhold anything. So when I make a video, I upload it, and that's it. It's immediately available to you. That's how I roll. So I kinda lost track of my thought at this point, so I think I will end the video here. But in any case, the number is going to hit 20,000 pretty soon, so thank you everyone. That was probably weird because the microphone is right here. In any case, thank you everyone. Have a nice weekend, or day, or night, or month, or whatever applies to you. Hanukkah is coming soon. Chag Sameach.